Proper and periodic sprayer calibration is crucial to accurately apply fertilizer and pesticides to your crops. Remember, each piece of equipment and each operator is different, so you're calibrating the sprayer not just for the product or application site, but also for the person using it. Calibrating a hose end style sprayer is simple and easy if you follow the method outlined in this program, and it should only take about 15 to 20 minutes of your time. This calibration method is infinitely scalable, meaning that the same steps listed can be used to calibrate a 1-gallon hand pump sprayer or a 300-gallon hose end pressurized sprayer. In fact, this calibration method is compatible with any combination of hose and nozzle style sprayers. Frequent calibration helps prevent over or under applying fertilizers and pesticides, saving you money, protecting the environment, and ensuring legal compliance. Under-application can lead to weak turf and poor pest control, while over-application risks plant injury, environmental harm, and illegal usage. Ultimately, poor calibration wastes time and resources. While it is possible to complete sprayer calibration on grass or another pervious surface using this method, it is highly recommended that calibration be completed on concrete, blacktop, or other impervious surfaces. If performing this calibration method on grass, you must add enough dye or colorant to the solution to visibly track where the sprayed material was applied. Before calibrating a sprayer, it's important to designate a helper. This method works best with 2 people, one to operate the sprayer and one to record the spray time. Check that all sprayer parts are functioning properly and that there are no leaks. If necessary, adding colored dye to the tank can assist in identifying any leaks. Nozzle selection can vary depending on the site or what you're targeting. Here are a few general guidelines to help choose the right one. Flat fan nozzles are best for backpack or handheld pump sprayers, especially when working in turfgrass areas. Full cone nozzles are ideal for high-volume hose end sprayers that need to cover large areas. Adjustable cone nozzles or nozzle hoods are typically used for very large applications like ornamental beds or garden spaces. To perform an accurate sprayer calibration, you'll need the following tools: a properly functioning sprayer, a measuring container, ideally marked in fluid ounces. Metric units work too, but you'll need to do a conversion afterward. A timing device, a stopwatch or smartphone works great. A measuring tape, and marking paint for impervious surfaces or wire flags or cones where paint applications may not be applicable. This calibration method only works when the square footage of our test area, in effect the calibration course, is 340 square feet, which is exactly 1/128th of an acre. There are also 128 ounces in a gallon. Therefore, using a 340 square foot test area will give a direct translation to gallons per acre, or GPA, after the timed outflow of water is collected and recorded. For this scenario and simplicity, we used a plot measuring 18.5 feet by 18.5 feet to total 340 square feet, but it can be in any configuration totaling 340 square feet, and marked it with these cones and flags. Fill the sprayer with water to half capacity. This will represent an average weight load during the course of an application. A good safety tip to remember, when possible, prepare the sprayer on a table or countertop or tailgate so that you can reduce muscle strain on your back when donning the sprayer. Apply a constant pressure and begin walking. Walk at a normal, casual pace, the pace at which you would ordinarily make an application. Begin spraying the material once your nozzle is inside the test area. Keep the nozzle at a constant distance from the ground. Refer to the nozzle manufacturer's guidelines for the proper distance to target measurement. Spray the entire test area while someone is recording the time it takes for you to cover the area. Start recording the time when the applicator begins spraying inside the test area, and stop recording once the applicator reaches the opposite side of the test area. The applicator will need to turn around to make the returning pass. The time should stop during the turnaround. Time should not continue to run anytime the applicator is turning around or not spraying within the marked area. For example, when the applicator reaches the opposite side of the marked area, time should stop while he or she is turning around to begin the next pass. The time will be compounded with each stop and start event. The clock should not run continuously during the entire exercise. Record the total time it took to evenly cover the entire testing area. Repeat the process 2 to 3 times to find an average run time. For this example, the total time was 52 seconds. Next, you will point the sprayer nozzle into the measuring container. Engage the sprayer to deposit water into the measuring container for the same 52 seconds that was recorded to spray the measured area. Make sure to use the same constant pressure from the previous step. Read the volume of water from your measuring container. This test captured 45 ounces during the 52 seconds. The volume collected during the previous step will be the sprayer application rate in gallons per acre. For example, if you collected 45 ounces of fluid in the test, your final rate will translate to 45 gallons per acre. Repeat the collection process 2 to 3 times and take the average volume collected to determine the sprayer rate in gallons per acre. The more times you repeat the process, the more accurate your results will be. As mentioned earlier, if you're using a metric measuring container, you will need to convert milliliters to ounces. For reference, we know that 1 milliliter equals 0.033814 fluid ounces. For your conversion, take the milliliters collected, then divide by 29.574 to determine the amount in fluid ounces. With many differences between applicators, such as walking pace and pump applied pressure, calibration of your equipment for each individual is important in order to assure a high level of application accuracy. Environmental and monetary waste can be avoided with regular calibration of your application equipment.